Members of the United States Congress are legally allowed to trade individual stocks. They just have to tell you about it. The Stock Act gives them up to 45 days to file the disclosure, which means by the time a trade is public, the setup is anywhere from a day old to a month and a half old. There is an entire industry built on selling you that data back. Subscription dashboards, alert bots, copy trade services. Most of them show you a leaderboard and a green number, and none of them show you how that number was calculated. So today, we are building our own, a local application that pulls the public filings, measures the reporting lag on every single one, simulates a fixed size paper position on the trades we choose to follow, and prices the whole book from free market data. No broker connected, no API keys, no subscription. It runs on your machine, and the database is a single file you can open and inspect yourself. Every prompt I use in this build is in the companion guide in the Alpha Cartel Discord. Link is in the description. First prompt creates the project folder and the single app file, and installs the two dependencies, Flask and requests. That is the entire dependency list. No data vendor, SDK. No broker library, no charting package. At the top of the file, we set the rules of the system as constants, so every one of them is visible and arguable. The maximum acceptable reporting lag, the fixed dollar size per simulated trade, the exit window, and how far back in time the simulation is allowed to reach. When someone asks how the number was produced, you point at those 4 lines. Second prompt builds the schema, 5 tables. Trades holds every filing we ingest, with a hash on each row, so rerunning a sync never duplicates anything. Politicians holds the copy trading toggle. Positions holds the simulated book. Prices is a local cache, so we are not hammering a free endpoint every refresh, and a small meta table records the last sync time. Notice what is not in there. No account table, no order table, no credentials. There is nothing in this database that could reach a real market. Third prompt writes the fetch layer. It walks a list of mirrors, takes the first one that answers with real data, and falls back to a local JSON file if none of them do. Every request is wrapped, timed out, and logged. A dead endpoint produces a warning and a fallback, not a stack trace. One thing to know about the sources, because it decides the shape of the whole build, the dataset you actually want is the one that carries both dates, the day the trade happened and the day it was filed. Plenty of published files carry only one, and if you build on one of those, you cannot compute the reporting lag at all, and your filter is fiction. So the normalizer checks for both dates on every row and throws the row away if either is missing. It also handles the case where a source wraps several trades inside a single filing, flattening that structure out and pulling the filer name and the filing date down onto each trade. There is a second source slot sitting empty in the config, and that is deliberate rather than unfinished. Free, current, machine-readable coverage is not evenly available across both chambers, and I would rather ship one source that is actually live than 2, where one is quietly years out of date. Bad rows get counted, not crashed on. Junk dates, missing tickers, scanned PDF placeholders. They are skipped, and the count is logged so you know exactly how much of the file you kept. Fourth prompt is the rule the entire build hangs on. For every trade, we subtract the transaction date from the disclosure date and store the result as a number of days. Anything over 45 days gets flagged. Flagged trades stay in the database. They are genuinely interesting on their own, and being able to sort filers by how often they file late is one of the more useful views in the whole application, but they are excluded from the simulation because a trade you learned about 2 months after the fact is a different trade. Fifth prompt builds the paper book. The rule is narrow on purpose. One position per qualifying trade. Buys only. A ticker has to be present. The filing has to be on time. The filer has to be on your copy list. And the entry date is the disclosure date, not the transaction date. This is the decision that separates a simulation from a fantasy. You cannot copy a trade before it is public, so the model does not get to either. Every position opens at a fixed $1,000 and gets a planned exit inside a 60 to 90-day window, targeting 75 days. When the clock runs out, the position closes at the price on the exit date and moves to realized. Sixth prompt handles pricing, and this is the part of the build I want you to look at hardest. We pull daily closes from a free source, fall back to a second free source, and cache everything locally, so a refresh costs nothing. And when neither source has the symbol, which happens because these filings include bonds, funds, and private entities, the position is marked unpriced and it stays out of the performance math entirely. It is visible, it is labeled, and it contributes nothing to the portfolio value. That is uncomfortable to look at, and it is the correct behavior. A dashboard that always has a number for everything is telling you something about its confidence that is not true. Seventh prompt exposes everything over a small REST layer. One endpoint returns the whole dashboard payload, metrics, leaderboard, holdings, recent filings. One endpoint kicks off a sync in a background thread and reports its stage while it runs, so the interface stays responsive on a full ingest. One toggles a filer on or off your copy list. One is a health check. The metrics are deliberately plain: total filings tracked, average reporting lag, simulated portfolio value split into what was deployed and what the book has made or lost, and a win rate that tells you what it was calculated from. Closed positions where possible, and openly labeled as unrealized when nothing has closed yet. A win rate without a denominator is decoration. Eighth prompt adds the 3 questions the metric cards cannot answer, and every one of them runs off data already sitting in your database. No extra requests, no keys, nothing to sign up for. First, sales are disclosed too. If a filer files a sale of the same ticker before our scheduled exit lands, the position closes on their filing instead of on the calendar. You are no longer guessing the exit. You are following the one they told you about. Second, the decay table. Same positions, same exits, but entered on the filing date, then 10 days later, then 27 days later. That third row is the honest one, because that is roughly the average delay across the whole dataset. If the average return collapses between the first row and the third, then whatever edge exists is living entirely inside the reporting lag, and the whole build has just told you something worth knowing. Last prompt writes the interface. Dark terminal styling, 4 metric cards across the top, the filer leaderboard with a copy trading toggle on every row, the simulated holdings table, and the full disclosure feed with search and filters underneath. The leaderboard sorts on simulated performance where it exists and falls back to activity where it does not. The disclosure feed filters by filer, ticker, side, chamber, and whether the filing was late. All of it is one HTML string served from the same Python file. Let us run it clean. One command starts the server, the database initializes itself, and because it is empty on first launch, the sync fires automatically in the background. You can watch it move through the stages: fetching, storing, simulating, pricing. Thousands of filings go into SQLite. The filer list gets built, and the most active filers get enabled on the copy list by default, so the dashboard is not empty on first look. And here is the state of the book. Total filings tracked, the average reporting lag across all of them against the 45-day threshold, the simulated portfolio value, and the win rate with its basis printed underneath it. Turning a filer on adds their qualifying buys to the simulation. Sync again, and the new positions get priced. Turn them off, and they stop generating new positions. And this view is worth the build on its own. Filter to late filings, and you are looking at the disclosures that arrived outside the window the law sets. Whatever conclusion you draw from that is yours to draw. The tool just makes it visible, and this is the table I would look at first. Entering on the filing date, 10 days later and 27 days later, over the same positions and the same exits. Whatever that spread looks like on your data is the actual finding of this build. You will also see positions sitting unpriced. That is not a bug in the build. That is the system declining to make up a price for a symbol that free data does not cover. So that is the build. Public filings ingested from free endpoints with a fallback path when they fail, a reporting lag measured on every row and enforced as a filter, a paper book that enters on the disclosure date at a fixed size and exits on a schedule, a price layer that admits what it does not know, exits that follow their disclosed sales when those exist, a decay table that shows what the delay costs you, and an index yardstick next to the portfolio number, and a local interface over the top of all of it in one file with two dependencies. The edge here is not a signal, it is structure and discipline, knowing exactly how a number was produced and being able to change the rule and watch what happens. The companion guide with every prompt from this video, the full reference code, and the verify commands is in the Alpha Cartel Discord, link in the description. If you build it, post your dashboard in the channel. I want to see what your lag distribution looks like, because it will not look like mine. One last thing, and I mean it. This is an educational build. Nothing in it is financial advice. Nothing in it places a real order, and disclosure data is transcribed from public filings and does contain errors and gaps. Treat the output as a research artifact, not a signal. If this is the kind of build you want more of, subscribe. I will see you in the next one.